Welcome to the session. My name is Nick Colt. I'm the General Manager of Amazon ECS, the Elastic Container Service. Really excited to be here today, and I'll be joined later on stage by Akhilesh Reddy, who is a VP at Goldman Sachs, and he's got a really great story to tell about the journey that they went through at Goldman Sachs with ECS Fargate. So what's on the agenda today? First, I'm going to spend a little bit of time sharing with you all some of the basics of ECS and how I think about ECS, how the team thinks about ECS, that can hopefully help you understand what ECS is and what it can do for you and how it can help with your business, with your enterprises. And then we'll spend some time talking about some of the new things that we've launched recently that you may have heard of, you may not have heard of, that you might be interested in, and would be happy to chat about those things after the talk to give you some more information on those. And then we'll hear from Akhilesh, and he'll go through this fantastic story that I mentioned that really brings together a lot of the things that I'm covering in my part of the talk. And then we'll get into what's next on the roadmap. So that's kind of the agenda for today. So first I want to spend a little time talking about what is ECS, Elastic Container Service. What does that mean exactly? It means a lot of things, but one of the things that it means is the control plane. The control plane is the part of ECS that orchestrates your container workloads. That means that it makes sure that a container is running when and where it's supposed to be running. It makes sure that things like load balancers are connected to those containers in the right way. And ECS's control plane, you don't hear people say this a lot, but it's a serverless control plane. What that means is that to use the control plane, you don't have to set up any servers, you don't have to provision any resources, you don't have to do anything other than start using the APIs. That's how a lot of AWS services work. That's how most AWS services work. They have a control plane that just works and it's there when you need it. But it's important to emphasize that point because that means that there's no management overhead associated with that control plane. You don't have to think about it. And it works at a scale from very small. You can start at very small scale, one container, one task, all the way up to 25,000 or more containers. We'll talk a little bit later about some of the scale numbers behind ECS. And of course, this control plane, when you run containers in AWS Cloud, is completely free. You don't pay anything to use that control plane. So that's one of the things that ECS is. It's a serverless container orchestrator. Serverless because the control plane is serverless. Well, that's part of the story. But of course, a control plane by itself isn't very useful unless you actually run some containers. And so where do your containers run? How can you run containers? Where are the different places and types of compute that you can run containers with ECS? And the term that we sometimes use is the compute engine. We also sometimes say the data plane. You might hear people use those terms interchangeably. And ECS, with that same massively scalable control plane, can run containers on a variety of different compute infrastructure, ranging from on-premises, can be literally a Raspberry Pi sitting on a desk or in a closet somewhere, all the way to serverless, the serverless compute engine, which is AWS Fargate, where you can run containers in the cloud with no EC2 instances that you have to manage. And it can also run on EC2 instances and Outposts. It can run on EC2 instances in AWS regions. It's the same control plane across the board, and people really like the consistency of that experience across all of those environments. That's one of the things that people like about ECS. One of the most popular options is Fargate. Why? Because when you pair that serverless control plane with a serverless compute engine, now you've got serverless end-to-end. And so let's talk a bit more about what Fargate is. Fargate is a serverless compute engine for containers. So what that means is that when you use ECS as your control plane and you provision services and tasks and clusters in the ECS APIs, and you use Fargate as the compute engine, your containers, which are inside of what's called a task, will run without a server that you have to manage. You never have to go to the EC2 console and pick an instance type and pick an AMI and then click start the instance. You never have to upgrade the operating system or patch it because it's gone. There is no such thing as far as you're concerned. There is one, but we manage it for you. It's completely managed. You don't see it. You're not charged for it. What you pay for is the containers that you run. And if there's no containers running, you don't pay on Fargate. And so you put those two things together, ECS as this massively scalable serverless control plane, and Fargate as this serverless compute engine, and that's a really nice combination. That's a very, very popular combination. I'm going to share a statistic later on a slide, but this is one of the reasons why ECS with Fargate is one of the most popular options for people who are running containers on AWS and they haven't run containers on AWS before. The majority of those customers are choosing ECS, specifically ECS with Fargate, because of the simplicity that it gets you. There's a bunch of other things that it gets you too that we'll talk about. It's like on the security side, I'm going to talk a bit more about why Fargate is secure. It also gets you savings, not just operational savings, because you don't have to have a whole team of people managing clusters of instances, but cost savings on your AWS bill as well, because of the pay-as-you-go pricing model. On the other end of the spectrum, from Fargate, is ECS Anywhere. So that's another compute engine or data plane option for ECS, where it's the same control plane. It's the same control plane running in the cloud. You manage your resources using those ECS APIs the same way that you would if you're running on Fargate. But the actual containers can run on hardware that you own. It could be in your data center, could be on your desk, could be your laptop. Or we've had someone on my team who had a cluster of Raspberry Pis sitting in their closet that was an ECS cluster. And some of the use cases here are data processing workloads where maybe that data can't leave a certain location, like medical records. You're doing medical image processing, and it's in a country where those are required to stay in the hospital. So what you can do is you can have the actual data processing be running in a container sitting in a server in that hospital, but the workload is being orchestrated by the ECS control plane running in the cloud. So that's an example of the type of things that people are using ECS Anywhere for. And it's really nice because there's no stuff that you have to install other than the ECS agent on that hardware that you own in order to have that ECS control plane. You don't have to manage that ECS control plane. It's the same one that you get in the cloud. So kind of put it all together, why do people choose ECS? You know, I said that it's the most popular choice for customers who are running containers on AWS for the first time. So why is that? And this is really where we think about how we help our customers achieve their goals. So faster time to market. If you're building a new product, a new service, and you want to get that out the door quickly because your competitors are moving quickly too, and the faster you can get to market, the better you're going to be able to achieve your business goals. Whoops, accidentally went forward there. And so what people really like about ECS is the fact that with this lower operational overhead that you get with a managed control plane and with the serverless compute engine of Fargate, you have lower operational overhead. You don't need a bunch of people focused on operations. Instead, they can focus on building your product and building your service. And there's no upgrades that you have to deal with. That you're not upgrading the control plane or dealing with compatibility between different add-ons. And all of that means that you get to market faster. Lower costs is another one. With the Fargate pricing model, you pay for the containers that you're running, and you don't pay if you're not running any containers. If you scale up, you pay more. You scale down, you pay less. You're not managing utilization. You don't have to think about what is the utilization of my cluster. When you run containers on EC2 VMs or you run containers on your own hardware, you have to think about utilization. Utilization is, I've got a certain amount of CPU and memory on that hardware that I'm running. How much of that am I actually using, and how efficiently am I packing all of those containers into all of those instances? And it's really hard to get that right. It's hard to do better than about 50% utilization on a cluster. With Fargate, you're not managing utilization. It goes away. You're not paying anything if you're not running anything, and you only pay for the containers that are running. Security is another one. So because ECS is an AWS service, it works out of the box with IAM. So all of the same roles, the same policies that you define in IAM, they work with ECS. It has a pretty long list of security certifications, compliance certifications that we'll go through later. Integrates with other AWS security services, and also with Fargate, and we'll get into how, but Fargate offers a really unique level of isolation in the data plane that you actually don't get when you're running containers on EC2. And so you put all these things together, and this is why people are choosing ECS. These are kind of the three big things that we're seeing. And we're really aiming to double down on these in our product roadmap, and you'll see that in some of the things that we've launched and some of the things that are coming. I want to talk a little bit about the scale, because sometimes people ask, how big can we get on ECS? It sounds like it's great if you're just getting started. Does that mean that we're going to outgrow it? Does that mean that our business is going to get too big and we're not going to be able to run on ECS anymore? Well, I want to tell you a little bit about the scale of ECS. So the core unit of compute on ECS is a task. You probably know that already. That's a group of one or more containers. And ECS, that control plane that I talked about, is responsible for ensuring that when a customer wants to run a task, that it gets run. We call that a task launch. And we do, right now, 2.25 billion of those per week worldwide. So that's kind of gives you a sense of the scale that ECS is operating at. It's pretty big scale. There's thousands per second. And in fact, that scale, although it is huge, we're continuing to focus on performance, on making that 2.25 billion number even bigger, because we want our customers to be able to move as fast as possible. And there are many different processes where the speed at which you can launch containers and the rate at which you can launch them actually does determine the agility of your developers. So one of those is around the throughput of our control plane. Not the aggregate throughput, which is that 2.25 billion number, but the individual per customer throughput. How many tasks can I launch per second? If you're a small customer, you might never run more than 20 or 30 at a time, and you might not care. But then as your business grows and suddenly you're running 500 or 1,000 or 2,000 tasks, and now you want to go do a deployment, the speed at which you can deploy those tasks matters. And so we've worked really hard to improve the speed of launching tasks in ECS, which then increases the speed with which you can deploy. And we have customers, like we had one customer that was launching 500 tasks on EC2 instances, and then there's sort of two things that has to happen. There's the task launching and then the EC2 instances that have to scale. And back in 2020, that was taking them like 90 minutes to do, which is way too slow. Because of the improvements that we did throughout 2021, they brought that down to 15 minutes. We had another customer that was deploying 100 tasks. That's a pretty good size service. It was taking 5 minutes to do that. And we brought it down under 90 seconds. So now they can do a deployment in 90 seconds. You might think, well, what's the difference between 5 minutes and 90 seconds? But if you're a developer, and you deploy, you have to wait 5 minutes. I mean, I've been a developer, and I know how frustrating it is to be like working on something and then, oh, I have to sit and wait 5 minutes. What am I going to do for 5 minutes, right? it's really unproductive. The shorter you make that development loop, the more productive the developers are. The quicker you're going to discover a defect, right, and fix it. You want that inner loop to be as fast as possible. So this speed at which you can deploy on ECS is actually impacting developer productivity. What I love about the ECS control plane is the fact that as a customer, you didn't have to do anything to get this benefit. You just keep using ECS, and one day it's faster, and the next day it's even faster. That's the benefit of a managed service and a managed control plane. There's nothing that you have to do. There's no button you click. You don't pay more. It just happens. Security, I mentioned this before. I'll go into a little bit more detail here. And in particular, I want to talk about the Fargate security model. So of course, we have a number of certifications for compliance. We've implemented best practices that enable customers to implement least access controls using IAM and security groups like network security. And that's all kind of standard, like we have to be doing that. What's pretty special about Fargate is what it does in the data plane. So I'll get a little technical here. When you run a container on a Linux machine, that container is actually just a process. That's what a container is. It's a Linux process just like any other process. And it is isolated from other processes on that same host using the Linux kernel. And that is reasonably secure, but there have been issues where there's been the ability to actually break out of a container through the Linux kernel into other containers on the same host. It's not common, but it does happen. Now, Fargate, on the other hand, when you run a task, let's say you have a task that has one container in it, and you run that task on Fargate, what we're doing behind the scenes is we are running that on a dedicated host. And so there are no other containers on that same host. So even if there was some sort of issue in the Linux kernel that allowed that container to access the kernel in a way that wasn't intended, there's nothing for it to do. It can't get to anything else because it's isolated through a virtual machine boundary. And this is a level of isolation that you don't get through other ways of running containers, like running on a VM using the standard Linux container methods that are out there. And so this is something that's really special about Fargate is that you get that isolation by design in Fargate. You know that you're not going to be exposed to those type of container security issues. Now, the containers in a single task, they are running on the same host in Fargate, but it's usually expected that the containers that are in the same task should have access to each other. There's a reason they're running in the same task. They're providing functionality that is tightly coupled, and that's why you put them into a task. And so this is really important if you have workloads, for example, that have different sensitivity levels, and you want to make sure that they're isolated from each other. That happens automatically on Fargate. You don't have to do anything. And so security is something also that we're just continually innovating on. We're continually investing in adding capabilities both within the data plane and control plane of ECS as well as through the security services that AWS offers. On that same topic of scale and security, one of the things that you benefit from when you're an ECS customer is the fact that ECS powers Amazon. That actually there are a number of AWS services as well as Amazon.com consumer website services that run on ECS. And so people sometimes ask, are we, like I said before, are we going to get too big for ECS? And my response is, well, are you going to get bigger than Amazon? Because if not, you're not going to outgrow ECS. So don't worry about it. But more importantly, what you benefit from here is the fact that we are testing ECS for scale, for performance, for availability, and for security at a level that is beyond what most customers would ever ask for. But because we're doing that, you all benefit from that, right? You benefit from the scale that Amazon is running at. And so that's one of the reasons why I like to share this about ECS is those performance and security improvements that we're doing them for you, we're also doing them for Amazon, and we're going to keep doing them. We also have quite a number of partners that we work closely with. This is not a complete list in the areas of monitoring and logging and security and DevOps. ECS is actually quite extensible system. There's lots of different ways that you could do things. You don't have to just do it the way that CloudFormation would have you do it, for example. You can use Terraform. Lots of folks use Terraform with ECS. So with that, then I want to transition into talking about what's new. What are some of the new capabilities? And I want to spend the most time on the first one here. And just share a little bit about the philosophy of how we build features in ECS. We use this term working backwards from our customers. And what does that mean? That means we start with you and your problem. It doesn't necessarily mean that you tell us, go build feature X and we'll go build feature X. Sometimes it is that, but sometimes it's, I have a problem, you say that to us, and then we figure out what is your problem in detail and then go build a solution for that. And with ECS, some of the things that we've heard is that we really want to be focusing on applications and not infrastructure, that you as customers don't want to have to think about managing infrastructure. So applications first. The infrastructure should be customized only to the extent necessary to meet the requirements of the application. Scaling should be almost require no thought. It should just happen. And security and isolation need to be built in by design. So those are some of the sort of core tenets on our roadmap here. And so one of the big things that we launched earlier this week that I'm super excited about is this thing called ECS Service Connect that fits squarely within those tenets principles that I was just talking about for how we build features. So Service Connect gives you the benefits of a service mesh without you having to actually use a service mesh. And if you're not familiar with a service mesh gives you the ability to do things like load balancing requests between services, automatically retrying requests that fail, getting HTTP metrics like the number of requests and the number of failures and so forth as metrics automatically from the traffic going between your services. What Service Connect does is it gives you those capabilities without requiring you to actually use a service mesh. It's very simple. You give your service a name. You can specify a protocol like HTTP, port number. Now your service can talk to other services, and the traffic between those services will be managed using Service Connect. It's a very simple experience, way, way simpler than service meshes have been done in the past. So this is one of those things that it's faster time to market. In terms of our product management tenets, our product management principles, it's application first, right? Instead of saying, start with a bunch of networking infrastructure, we say, start with your application and how do they need to talk to each other? Which applications need to talk to each other? Which services need to talk to each other? So we've just launched this earlier this week. We have a lot of plans for it. Definitely encourage you to try it out. If you have feedback, requests that you want to feature requests that you want to give us, I'd love to hear those. We can chat in the hall afterwards, or we also have a public roadmap where we'd love to hear those kind of things. Another one that we launched recently on Fargate is larger task sizes. So when you use Fargate, one of the things that you do is you specify how much CPU and memory do I want this task to have. You can say 2 vCPUs and 4 gigs of memory, for example. And most of the time in a microservices architecture, it's pretty common to have fairly small tasks because you want to do horizontal scaling. You want to, if you need more CPU and memory, what you do is you run more tasks, you run more replicas. But there are some workloads where that doesn't work. You might be doing data processing where you have to be loading a big data set into memory on the same machine and have a bunch of threads all processing that data using shared memory. And you can't horizontally scale that. And so what we did is we added some additional options about 4 times bigger on CPU and memory. So now you can go up to 16 vCPUs and 120 gigs of memory. And that's one of the examples where what we're doing is we're investing in Fargate to enable more and more workloads. It's already one of the most popular options, but we really want to get to the point where there's virtually, I mean, there will always be specialized things, but where we get the vast majority of applications can run on Fargate, that we have the right set of capabilities so that you can run on Fargate. So GPUs is another example where that's on our roadmap. Like right now, you can't use a GPU with Fargate, but you'll be able to do that, which means you'll be able to do things like machine learning on Fargate completely serverlessly. So we're going to be continuing to invest in the performance and security and capabilities of Fargate, and this is just a few of the things that we've done recently. For folks that are getting started on ECS, the console is very popular. They use that to go through and get things set up like some of the infrastructure that they need, or task definitions, or services, or clusters. And so we're adding a whole bunch of things and workflows in the console to make it even easier to get started. Things like adding OpenTelemetry to your service with one click, for example. So that's another area that's a continued area of investment for us. Application-first interfaces. So we, in addition to building some of those constructs directly into ECS itself, we have a number of areas of tool sets outside of ECS that work with ECS. One of those is this thing called ECS Blueprints. What Blueprints is Terraform templates that are on GitHub that address a bunch of different use cases and application types that allow you to get started really, really quickly. And you can customize them using Terraform on ECS. CDK, the Cloud Development Kit, is a super popular option for infrastructure as code. Allows you to write in popular programming languages and have that translated into CloudFormation behind the scenes. And we have a bunch of extensions that allow you to do things specifically for ECS, and you can also extend those yourself. The Copilot CLI, the AWS Copilot CLI, is another one where we give you a very simple application manifest, and you can deploy that application using the Copilot CLI, and it will orchestrate the creation of load balancers and all the other things that you need in addition to ECS resources to get an application up and running on ECS. A bunch of other things that we did in 2022 as well that I don't have time to go through here. Like I said, we were making investments in richer compute options on Fargate and faster performance and scaling and launching in more regions. So that gives you a sense of the kind of things that have been going on. And so, I'll end with my part of the presentation, just reiterating the reasons why people choose ECS, that faster time to market, the lower cost, and the secure by design. And these are things that you're going to see in Akhilesh's presentation. So at this point, then, I'm going to hand it over to him, and I think you're going to love some of the stories that he has to share.
Hello, everyone. Hope you all are having a great day so far. My name is Akhilesh Reddy. I'm part of the cloud engineering team in the consumer banking division at Goldman Sachs. Let me kick it off with some business context, first of all. Goldman Sachs has a direct-to-consumer business called Marcus, which it launched in 2017 with a goal to build the consumer banking platform of the future and to address the spending, savings, borrowing, and investing needs of millions of customers and help them achieve their financial goals. Some of our products include a high-yielding savings account, a lending platform which offers personal and small business loans, co-branded credit cards which are offered through partnerships. Talking about our partnership with AWS in general, Goldman Sachs uses AWS across many of its divisions to deploy and run applications at scale. And even in our division, we have leveraged AWS extensively to build many digital banking platforms, primarily leveraging ECS Fargate. Let me give you an overview of our journey with AWS. And specifically, this is only our division, which is the consumer banking division. Our initial adoption on AWS started in 2017. And around 2018, we were running some of our consumer production workloads on EC2 instances. And that was the same year when AWS introduced Fargate and made it available with ECS. And it made us think about the strategy around how we manage the containers, the infrastructure, and the whole ecosystem around it. And so we made a long-term goal to leverage some kind of a fully managed cloud-native container orchestration engine, which basically reduces the overall operational overhead of us managing the infrastructure. And so we evaluated a few options, and finally we went ahead with ECS Fargate because that looked the natural choice to us, given we were on AWS already. And so we went ahead and piloted one of our workloads on ECS Fargate in 2019. This pilot resulted in one of our production workload being launched the following year, which is 2020. And it was, again, a financial product. And it worked pretty well. And it was meeting all our requirements around security and resiliency and availability. And so it also gave us the confidence to launch more and more diverse workloads on ECS Fargate. So in 2021, we launched a co-branded credit card which serves millions of customers, and that platform was majorly powered by ECS Fargate. As of 2022, we have multiple workloads running on ECS Fargate, and it has kind of become our primary compute platform to host our further platforms. Looking into 2023, I expect our usage of ECS Fargate to be even exponentially growing and to meet our business growth trajectories going forward. In the next two slides, I'll cover some of the needs and considerations or the factors which helped us in choosing ECS Fargate. Basically why people choose ECS Fargate. So that was the same question even we had. As a business, we had a need to launch our applications as quickly as possible, and I'm pretty sure every one of you also have a similar requirement too. And that was one of our first major decision criteria in choosing ECS Fargate. With ECS Fargate, we had less platform maintenance and building to do. We did not have to manage the underlying infrastructure or account for any OS hardening or do any sort of a cluster or container upgrades or design any great strategies around container bin packing or anything like that. Because a lot of these things were all natively managed by ECS. And that helped our teams to get more work done at a faster rate and also focus on some other key areas than managing this whole operational infrastructure and other things. And it improved our overall developer efficiency by leaps and bounds. Another major factor around deployment times, and I think Nick was covering that too. ECS in general helped us in reducing the time it takes to deploy a service. And thereby, it improved our overall deployment frequency rate so that we could iterate on our changes very rapidly, and it gave our developers the ability to push more changes very frequently, and it improved our overall developer experience a lot. So when we initially started on ECS, we were just running hardly few services, and from there, we have been able to scale to as many as 500 services across our application stack. And as of now, we are running over 25,000 ECS tasks in each AWS region. Bottom line, ECS helped us in meeting our accelerated timelines, at the same time reducing the operational overhead of managing the infrastructure, which helped us in launching a co-branded credit card in 2022 in very accelerated timelines. Continuing on with some other considerations. To meet some of our requirements around resiliency and availability, we wanted our workloads to be deployed in 2 regions in North America. And ECS Fargate was supporting it without any issues. One of the major factors around scaling, I would say, with ECS Fargate, a lot of dynamic scaling happens out of the box. Like we didn't have to provision any infrastructure around scaling whenever we wanted to launch more number of containers. ECS Fargate also promises to launch tens and thousands of containers in a very relatively short period of time for us. One major factor around security, I would say. ECS Fargate allowed us to run highly secure and highly regulated workloads. Let me stress upon that once again. We were able to run highly secure and highly regulated workloads on ECS Fargate because it was meeting all our security requirements that we needed. And in addition to that, it was also offering the flexibility to fence it with some additional security controls whenever we needed. So that way, we could host a variety of our financial products which have got varying levels of security requirements. And we were able to achieve them, we were able to install all of them on using ECS Fargate very efficiently. And while our usage of AWS, ECS Fargate in general was exponentially increasing, we still wanted to keep a tab on our infrastructure costs. I'm pretty sure everyone here also wants to reduce their infrastructure spend. And ECS helped us in achieving those cost efficiencies. And we were able to reduce our infrastructure spend by as much as 50% compared to our other traditional deployment patterns that we were using earlier. And we were following some of the best practices around how ECS costs can be optimized while doing this. Summarizing, those were some of the factors which led us to decide on choosing ECS Fargate and adopt it as one of our primary compute platform. In the next 2 slides, I'll talk about some of our design choices around our networking architecture, our multi-account strategies, how we are doing security governance at scale, and how we are doing our IAM segmentation controls, and basically how ECS was fitting into this whole ecosystem. We had some requirements around security, resiliency, and availability, where we wanted our workloads to be running on multiple regions. I'm pretty sure many of you might be already doing this or have some similar requirements to do this. We also wanted to have a clear segregation between the networking and application infra constructs so that it can be more efficiently managed by our network teams and application teams. We also wanted to give our application owners the flexibility to manage their own AWS accounts and their infrastructure with some set guardrails, but completely isolate all the networking complexity from them so that they could just focus on developing and deploying their applications, which could overall improve their developer experience. So how do we do this? So what did we design? So we designed something like this, where we had an AWS account dedicated for the centralized management of all the networking infrastructure. We were calling it as the network app account. We defined multiple VPCs in this network app account and interconnected them, all of them using transit gateways to basically form a hub-and-spoke design. We then leveraged transit gateway inter-region peering to connect the transit gateways in multiple regions to build a globally distributed network. We leveraged a concept of VPC sharing over here, where the VPCs which were defined in the network app account were shared with multiple individual application accounts, which the application owners could use to deploy their ECS services on the Fargate clusters which are owned by their application accounts. I'll talk more about this in the next slide more extensively. So what does this design help us with? This kind of a centralized network hub design helped us with centralized management of all the networking resources in a single AWS account. So we were hosting all the network level constructs such as VPCs, transit gateway attachments, route tables, network firewall managers, Route 53 domains, VPC endpoints, everything into one single account called the network app account, which was centrally managed by our network infra team. It helped us with centralized traffic monitoring and inspection, where we could centrally monitor all the traffic coming in and out of the network, and also we could apply our security governance policies at scale, all from a single AWS account. It helped us with centralized DNS management, where we could host all our cloud-specific DNS domains in this account and let all the application teams use it, and we could still centrally control them from this account. It also solved for the famous service-to-service communication problem. I'm sure many of you would also have the same problem when the services are spanning across multiple VPCs and multiple accounts, and in fact, multiple regions. Continuing on from the previous design, as I was saying, in our design, we wanted our application teams to manage their own accounts and let them deploy their own applications and let them manage their own accounts. So that way, they can independently deploy their applications in a more efficient way. As you can see over here, we have depicted the usage of Fargate clusters running in each and every other application account. So we were calling the application which the application owners were using it as application account. So basically, we had two accounts over here. The one on the top is the network app account, and the one on the bottom is the application account. So the concept I was talking about earlier around the VPC sharing, we leveraged a concept called VPC sharing, where the VPCs which are defined in the network app account were shared with the application account so that our application owners could just deploy their services onto their accounts and go ahead with that. So basically, if you are planning to visualize this in your head, so what this means is we are just trying to deploy a service into a Fargate cluster in an application account, but the VPC where this service is running on is not owned by the application account, but instead, it's owned by the network app account. So why did we do this? Why did we have to complicate this design like this? One of the main thing why we did this is we wanted to push all the network complexity or all the network level constructs from the application accounts into our central network app account, because we didn't want our application owners to understand the network complexity and the constructs around it. So this design helped us with pushing all those network complexities from our application accounts into the network app account. So that way, our developers don't have to understand how the networking is working behind the scenes, but just focus on deploying their services onto the Fargate clusters in their AWS accounts. We were able to achieve better isolation between the applications because every other application was running in its own independent account and in its own VPCs. So let's say if you wanted to delete an application or something happened, I could always just delete that AWS account or AWS VPC, and we are back in the business. We were able to achieve better isolation even at an IAM level due to this, where an IAM user, let's say an IAM user A, can only access the services in account 1, and an IAM user B can only access the services in account 2. And there is no crisscross between both of these accounts. In this design, each service would have network connectivity to the other service, even if they were hosted in multiple VPCs or region. So basically what this means is, let's say there is a service in VPC X of region X. It could still communicate with another service Y, which is sitting in VPC Y of region Y. So what did this design help us with? We achieved improved developer agility. We were able to improve our developer experience. We were able to improve our security posture by leaps and bounds. We achieved greatest levels of isolations that we wanted in terms of IAM and security. Moving on, now we have a problem. Now that we had installed our applications across multiple accounts and multiple regions, Our developers wanted a view where they could visualize all the running ECS services spanning across all the AWS accounts. ECS doesn't have an out-of-the-box option to do something like this. So what do we do here? So we went ahead and created a custom portal which gives a cross-account view like this, where you could visualize all your ECS services running across all your application accounts across all the regions. You could look at the view over here. It shows the service name, the cluster name, whether the service is up and running, and the number of tasks and the desired tasks. And we also extended this dashboard to perform some kind of a administrative tasks, such as scaling, starting, and stopping of the tasks. It also has an account ID column in this dashboard, but we just masked it for the sake of this presentation. Like, we don't want you to see our account IDs in general. We later integrated this dashboard into our internal systems, added the needed RBAC controls that we needed, and so that only authorized users can access this dashboard and they can do any custom actions that they need. Although AWS does not have an out-of-the-box approach to do something like this, the good thing, ECS exposes every single API that we needed to build a custom portal like this. So basically, ECS has all the APIs that anyone needs to build a custom abstraction like this. Before closing, let me recap it with some key wins that we had. I'll just go through a few of them, and I'll leave the others for you to read. Accelerated go-to-market. This was one of our first major key win, I would say, where we were able to launch multiple products over the last 2-3 years leveraging ECS Fargate. Reduced operational overhead. ECS Fargate in general reduces a lot of operational overhead around how you manage the infrastructure and how you scale the infrastructure. You don't have to worry about the underlying infrastructure or any sort of cluster optimizations that you typically have to deal with any other container platform. Let's say if you were to install on your own EC2 instances. Enhanced security posture. ECS Fargate helped us in achieving a lot of security enhancement. It basically improved our security postures by leaps and bounds. And I think Nick was also talking about the task isolation, which ECS Fargate gives you by default. So that way, we were able to install a variety of our secure workloads on ECS Fargate very effectively. Last thing I would cover is the cost efficiencies. With ECS Fargate, as Nick was pointing out too, you only pay for what you use. So technically, you are only paying for the time the ECS Fargate task or the container is up and running, rounded to the nearest second. So that way, you're not paying anything extra than what you're not leveraging or utilizing. That's it from me. Thank you all for listening to me. If you have any other questions, I'll be happy to answer them after this session. Over to you, Nick.
Well, I love that story. The combination of things that they were able to achieve is almost magical. And this is why we get out of bed in the morning, is to help customers succeed like that. So I want to then transition into talking about what's coming on ECS. And I hinted at some of these things before. And I probably won't go through all of these things, but I'll talk about some of them. Some of the big themes I think that you're going to see here is around developer experience, around application first, and around performance. So let's talk about the developer experience part first, both deployments and developer experience. And in particular with deployments, we talked about this already, that as a developer, the speed of deployment is actually critical to your agility. And not only is the speed of deployment critical, but confidence in deployment. Confidence that if it works, you can proceed, and if it doesn't work, you're going to know it and you can roll back. And that's why strategies like Blue, Green, and Canary exist, because you want to give developers confidence. When you give developers confidence, it's going to make them faster, and the faster developers are, The faster you can get to market, the faster you can iterate, everyone is happy. So ECS does have the ability today to do a blue-green deployment through code deploy. It comes with some requirements, and those requirements don't always work for customers. It also has a rolling deployment capability. But what we wanted to do is kind of go back and take a look again at how deployments work in ECS, because it's so critical to developer agility. And so what we're doing and what we're working on is a native, when I say native, I mean it's built into ECS. You don't have to go use another service, a native capability for doing blue-green and canary deployments. So a blue-green deployment, if you're not familiar with that, is where let's say you update a container, you update the code in the container, you build a new container image, you update the task definition, and now you want to go roll out an updated version of that service with a bunch of copies of that task running. You want to do that in a way that there's no downtime, right? If you're sending traffic, production traffic to that service, you want to be able to flip over to the new one. And that's what a blue-green deployment is. You start up the new one. Once it's healthy, then you flip over all the traffic, and then you shut down the old one. And so we're working on, coming soon, the capability to do that natively within ECS when you're using an ECS service. Canary deployment is kind of a variation of that, but instead of flipping everything all at once, you do it progressively. You say, well, I've got this new version of a service, it's updated code, it's got some advanced functionality. Let's roll out a little bit. Let's do like 10% to the new version and 90% of the old one. Let it sit there for a while, make sure that everything is working, and then start ramping it up. And with both of those, with blue, green, and canary, you really want the ability to be able to flexibly control how do you detect when it's not working and then roll back. And that's going to be built into the capabilities that we're building. And that's super important, like I said, for developer agility, because the more your developers understand and have the ability to deploy quickly and roll back quickly, the faster they're going to move. On performance, we have a bunch of investments we've already made in the task launch rate, the ability to launch tasks. We have a lot of customers who run on EC2 as well. They run containers on EC2. They're doing things like GPUs, or they're running huge data processing workloads, or other things where Fargate isn't yet a fit for them. And so for those customers, we've already launched a few years ago the ability to automatically scale the cluster in and out. But what we're investing in is making that scaling in and out process faster, so that when you have a bunch of containers that you need to run, you get the compute infrastructure that you need more quickly. And then when you don't need it, it scales in faster. This is going to give customers running ECS with EC2 as their compute engine. I wouldn't say it's going to be just like Fargate, but it'll be more Fargate-like, in that you'll be more likely to only have the infrastructure running that you actually need to have in order to run your containers. Storage is another area we're investing. So you already have the ability to use Amazon EFS, Elastic File System, which is a shared regional file system that you can attach to ECS tasks. We're going to be adding FSx Lustre, which is a file system that's a managed file system on AWS that's aimed at high-performance computing workloads. I talked about this already, but on Fargate, GPU is one example of something that we're going to be adding, where we're expanding the capabilities, better performance. We're going to continue to be working on task launch rates, as well as task launch latency on Fargate. How quickly from the time that you try to launch a task is it up and running. That's another aspect of performance that we're investing in. One thing that I probably should have put in the things that we recently launched, we kind of got into this slide because it launched while we were working on the slides, is a feature called Task Scale-In Protection. So if you're running a service and that service is doing work that you don't want to interrupt, you don't want to scale in and then have the scale-in process terminate the task that was actually doing work. Gaming servers is an example of that. That's actually where this feature came from initially, was a request from customers who run like a persistent game world in an ECS task, and they've got like people actually connected to it. in a shared game world. You don't want to scale that in while people are still connected. And so what task scale-in protection does is it gives you the ability to mark a task as protected from being scaled in, and then ECS will make sure that it doesn't get scaled in. On the networking side, I already mentioned the Service Connect launch. What we have today with Service Connect is just the beginning. So security is an area where we're going to be investing specifically on Service Connect with things like end-to-end encryption. So today, if you're running services and you want to have TLS encryption for all the communication that happens between those services, it's really on you to manage that. With Service Connect TLS end-to-end, you'll be able to enable encryption without having to change your application at all. Actually, your application won't even know that it's encrypted. It doesn't have to know. Your developers don't have to deal with that either. And then eventually, we're also looking to add a capability called mutual TLS, which goes beyond just encryption to actually do service-to-service authorization. So you give a service an identity, and then other services can verify that identity using TLS, and then can accept or reject connections based on the service identity. So this allows you to have another layer of security at the application level for which services are allowed to talk to which services. And so if you go back to those kind of reasons why people choose ECS, you can actually bucket most of these things into one of those buckets: faster time to market, lower cost, or security, right? And I'm really excited for the roadmap that we have coming. We actually also have a GitHub roadmap. I'll leave this slide up for a little bit, and if I remember correctly, that's a 1, not an L there, so it should be S18, yes, although I could be remembering wrong, and hopefully I'm not. Somebody try that out and see if the URL works. So that's our containers roadmap on GitHub. And what's really nice about that is that you can see the things that we're working on. You can see requests that people have been put in. You can see comments that people have made. If you have a GitHub account, you can go put in a request yourself for a capability that you'd like to have in ECS. You can participate in the conversations. We look at this all the time. We also have a YouTube channel called Containers from the Couch, where some of the developer advocates are doing demos, doing walkthroughs of new features that have launched, sometimes talking with customers and partners. So I encourage you to check that out as well. And so speaking of developer advocates, this is the developer advocate team. These are their Twitter handles here. These are folks that focus, as the name implies, specifically on helping builders, on helping developers understand and use ECS. And so these folks, more than anyone else, are actually product experts in ECS. They really know all the different ways that customers are using ECS. And they love people reaching out to them. Get in touch, ask them questions, have a conversation on Twitter, or send them a direct message and get an email conversation started up. They'd love to hear from you. I'll end with a bunch of the other sessions that are happening. Some of these have happened already, but this is kind of the full suite of ECS and Fargate sessions that are happening here at reInvent. If you haven't been able to check all of these out, I encourage you to watch some of them on YouTube after. A lot of the folks from that developer advocacy team and other folks on my team are giving these presentations. We've had some on Service Connect and Fargate that really go in depth on some of these topics. So I encourage you to check that out if you're interested. With that, thank you very much. It's been great having you all here. Really excited to tell you about all this stuff and to hear the great story from Akhilesh. And we're not going to do questions at the microphones up here. We'll just kind of go out in the hall there if folks want to chat after the session. So thank you very much.